So this week we are working on heat capacity and related topics, and I just wanted to go over a few things real quickly for you. So whenever we're looking at a system or its surroundings, there's going to be a flow of heat between the two if the temperatures are different. So the classic example of this, and by far the easiest one to use when we're looking at these problems, is you have a bucket of water and you drop a hot block into the water. Okay, a block of metal, block of wood, whatever. The block is hotter than the water, and so it will lose heat to the water. Now, in this instance, our block is what we are calling the system, and the water is the surroundings. So these two terms, system and surroundings, it really doesn't matter which one you assign to the block or the water. The reason why we draw this diagram, what I like to refer to as a block in a block diagram, because it looks like one box inside of another box. The necessity of drawing this diagram is simply to get the sign of heat flow correct. If we have energy leaving, if we have heat leaving the block to the water, then the energy for the block is going to be negative. It's losing heat. The energy for the water is positive. It's gaining heat. These signs are not arbitrary. They're specifically referring to the loss or gain of heat. So when we try and figure out how much heat is being lost or gained, those signs are really important. Now, like I said, it really doesn't matter which one you assign as the system or the surroundings. The important thing is understanding the direction of the heat flow, so positive or negative. Now, in these simple problems, when we're looking at these two objects, in this case our block and our water, what we're really comparing here is not just the heat flow itself, but how much heat. And that's going to be dependent upon two or three things here. Temperature. There has to be a temperature difference between the two. If they are at the same temperature, there will be no net heat flow. Okay, so the net amount of heat lost or gained from either the system or surroundings will be zero. Temperature dictates heat flow because heat always flows from high to low temperature. Heat always flows from high to low temperature. If you take a hot object and put it next to a cold object, the hot object will cool down, the cold object will heat up. Energy will flow from high to low temperatures, always. Now, there are two other factors in here that are going to affect the way heat flows between the block and the water. The mass. So how much mass of each you have is going to dictate how much energy flows between the two and the overall consequences of that energy flow. Now, no matter what happens, temperature is ultimately going to determine how much heat flow is going to take place. Heat flow will happen until temps are equal. Okay? If you take two objects, put them next to each other, touching each other, heat will flow between those two objects until they have the same temperature. And that's it. That's the end of the problem. Mass is going to dictate how quickly that heat flow happens. Mass is going to dictate the final temperature of the objects when heat flow is done. So mass is an important part of it. And then the other thing is heat capacity. I'm going to pretend I can spell here. Heat capacity. Specific heat capacity is what we're really after here. So there's a difference between heat capacity and specific heat capacity. Heat capacity is a really general term for how much heat an object can hold. So for instance, if we look at two pots of water. Let's say this one has 1 gallon of water in it, and this one has 5 gallons of water in it. These two pots of water, if we apply a flame to each, the pot of water on the right can hold more heat. It takes more time to heat the pot of water on the right up. This is heat capacity. There's more water, therefore it takes more heat to warm the pot up. Specific heat capacity describes the amount of heat required, or the amount of energy to raise 1 gram of a substance by 1 degree Celsius. So it's typically measured in joules per gram degree Celsius, or calories per gram degree Celsius. So it's specific, 1 gram per 1 degree Celsius. So how much energy is required, that's the joules and calories, to raise 1 gram of substance by 1 degree Celsius. So in a problem where we've got our warm block dropped into the water, we have these 3 factors, temperature, mass, and specific heat capacity, that are going to dictate how the heat flows. So of course heat is always going to flow from high to low temperature, but how much heat is going to flow and what are the final temperatures in the end, that's going to be dictated by the mass and the specific heat capacity. So now we're going to work on a couple practice problems. That'll be in the next video.